In this video I will introduce the LED output module. Now LED, as you know, stands for light emitting diode, and this module, as you can see, it consists of two LEDs, one red and one green, as well as this dual USB plug. The reason why there are two USB plugs in this fitting is because each one of these USB plugs is responsible for its own LED. Now, to demonstrate this output module, we are going to plug this into our microcontroller, and we have selected ports D1 and D2 on the microcontroller. So heading over to the scripting side, we can specify an LED attached to output D1 as well as an LED to D2. Now, starting out with a very simple script, we are simply going to specify that D1 should be fully switched on and D2 should also be fully switched on. Now, of course, before we can run any script, we need to save it. We're just going to save it under the name LED. Any meaningful name will do. After you've saved it, you can compile the script and then we can run it. And the moment we run it, you can see that both the LEDs lit up as requested or instructed by our script. Now, of course, if we stop the execution, the LEDs will switch off immediately because all the pins are being reset between the various runs. Now, of course, the various options that we have for LED is to switch it on fully, to switch it off, but we also have a dimmer function here. Now, the dimmer function is possible because of the microcontroller's output in the form of PWM, which stands for pulse wave modulation. Now, what happens is that instead of sending a steady current and stream to the LED to switch it on, it will actually pulse the LED, but it will do this so quickly that you won't be able to see the flicker of the LED. So instead, what you will witness is that it appears to have a dimming function. So running exactly the same script, we're just going to change the full on to a dimmer, and you will see that if you hover over the variable field, you'll see that you need to specify a value between 0 and 1023. So that leaves 512 exactly in the middle. 0, of course, would be equal to completely switched off, and 1023 would be equal to switched on completely. So, like mentioned before, 512 is exactly halfway. So we're going to leave the green LED halfway, and the red one, we're going to dim it quite a bit. Let's leave it on something very low, so it's just something like 4. And then, of course, we overwrite our script, we compile it again, and we run the new script. And you will see immediately that the green LED is running at 50% its normal duty cycle, and the red LED, although red LEDs tend to be, due to the nature, tend to be a lot more brighter than green LEDs, you'll notice that it's a lot dimmer, a lot more dim now than the green LED, and that's because of the PWM function that's running it on a pretty low duty cycle. Just to demonstrate with a little more of an interactive example, we're also going to introduce two timers here. So we are specifying our two timers here on top, and then instead of just switching on these LEDs, we are going to declare our two timers. So timer 1 and timer 2. And for timer 1, we would like it to fire every 3 seconds, and timer 2, let's leave it on 5 seconds, for example. Now, what we want is that if timer 1 triggers, then we would like our first LED, which is the green one, we would like it to switch on fully, and also we want the red LED to switch off. Whilst if timer 2 triggers, then we would like, exactly as before, just in reverse, we would like our green LED to switch off, while we would like our red LED to shine. So as before, we save our script, we compile it, and it seems like my dog's killing someone outside, and while the script is running, I'll quickly go and pick up the corpse outside. In the meantime, you can see the LEDs flashing. After 3 seconds, like we specified, it started flashing, and on second 5 it switches back to the green LED. And that's it for the LED output module.